Good morning, Algebra 2 students. I'm here to give you accommodations and interventions for Chapter 2, Part 2 test for Mr. Fry. First, we're looking for scatter plots. Number 1, what are the 3 general types of correlation a scatter plot can have? I have some examples for you, but you just have to name them. So, say you have a scatter plot that looks like this. Okay, that has a general name. Suppose you have a scatter plot like this. Notice the best line of fit would be somewhere in here for this one. What would you call that kind of scatter plot? Has to do with the direction of your data. And then this one has to do with the direction of your data. And then this kind, where it's just all over the place. So name those 3 types of correlations for scatter plots. For number 2, construct a scatter plot and find the slope-intercept form to construct a line of best fits for the data. So you're just going to start plotting these points. So 10, 700, 10, 700, right here, and so on and so forth. Go ahead and start plotting those. Remember, for your slope, you just grab one of the y's, and then another y, find the difference, and then go in the same order, whichever y you got. So say I grab this one first. Like these are my, like say I'm just grabbing these 2 just because they're the closest, okay? So, I'm going to take that 100 minus the 100, the 100 minus 1, or maybe a better one would be like this, because there would actually be a difference. So 200 minus 100, so I'd have 200 minus 100. So since I started with this one on the x, I'd go 100 minus 80, so 100 minus 80 in order to find the slope, okay? In order to find your y-intercept, I'm going to figure out kind of where it would be crossing the y-axis. Remember, this is your y-axis here. This is your x-axis. Okay? And then you would write so you would figure out the slope. You'd kind of figure out where where it crosses the y-axis, and then make that into an equation. For the following problem, list the type of transformation and how it affects the graph of the parent function. So the parent function is x cubed. So taking a look at this, I want you to look at these notes, and you could pause it if you want to. Find yours. These are from Mr. Fry's class. If you want to, zoom in on anything, my handwriting isn't the best, but I do have some choices for you. So I have some choices for your first 4, so this would be 1 through 4, and then 5 through 8 are going to be these choices, so you can come back to this, okay? So, you're going to have either vertical up, horizontal right, reflection, or vertical stretch. And the number, vertical up by how many, horizontal right by how many, is going to match these numbers. And if I gave you those numbers, I'd be giving you the answer. So, this one is either a vertical up, a horizontal right, a reflection, or a vertical stretch. Okay, and it's by 7 places. This one's going to be either a vertical up, horizontal right, reflection, or vertical stretch by that 2. This one's either going to be a vertical up, horizontal right, or reflection, or vertical stretch. And this one's going to be a vertical up, horizontal right, reflection, or vertical stretch by 4. Okay, so that's your 1 through 4 again. Your 5 through 8, you're going to have a vertical down, a horizontal left, or a vertical compression by these numbers. So this half x cubed is going to be either a vertical down, horizontal left, or a vertical compression by a half. This one's going to be vertical down, horizontal left, or vertical compression by 2. And this one's going to be a vertical down, horizontal left, vertical compression by 3. The description of the graph, so you're going to describe what happens on the graph. Well, it's going to move this way this many times, or you could be giving this the change in coordinate points, what happens with each coordinate point. So you could explain that also. So once again, you might want to utilize this kind of, blow this up and see how that corresponds with your answers, okay? Okay, moving on to 4 and 5. For the following problems, describe the transformation that happens to the parent function of y equals, and it's the absolute value of x. So once again, you're going to use these. You could use these. They're very similar. So when it's in the absolute value bars and you have a -3, I'm telling you it's going to be, either a horizontal right or a horizontal left here, okay? And it's going to be by 3 units, and that's going to be your description. So I'll give you a little help on that. And then number 5, when it's outside the absolute value. So I'm going to tell you that this is either a vertical up or a vertical down by how many units. That's going to be your description. Says returning to this, it's going to be, I have the absolute value function. How does this absolute value function, how does each variable affect the absolute value parent function if A, this part is greater than 0, if H is greater than 0, and if K is greater than 0. And then each part if they're less than, okay? So what's going to happen, and this kind of helps, this is from another class, and this might help you. So the A part is the dilation, okay? So, if it's going to be greater than 0, it's going to, make it bigger. If it's going to be less than 0, it's going to be, shrinking, stretch or shrink. And then you have this, it's the translate right or left. So if it's greater than 0, so if it's not negative, if it's, greater than, we're going to be moving left. And if it's less than, we're going to be moving right if it's a negative. And then we have translate up or down. So if the K is a positive, it's going to be going up. And if it's negative, it's going to be going down. So that's a lot of help in explaining these. Pretty much I said all those. So you might want to rewind that, come back, and I told you for all of these greater than and all of these less than. A lot of help with this diagram right here. For number 7, where is the vertex always located? Well, you have this here too. The vertex is located wherever your H and K are, okay? And, give those coordinates. So that's a lot of help for number 7 too. Number 8, when do you use a dashed line when graphing two variable inequalities, and when do you use a solid line? Okay, one of them has to do with greater than or less than, and then the other one has to do with greater than or equal to, less than or equal to. Okay, you're going to use that in your answer for number 8. For number 9, have an example drawn here. What do the shaded and non-shaded parts represent in a graph of a two variable inequality? So, what does the shaded area mean, if I pick points in here? If I pick points outside the shaded area, what does that mean? So one of them is going to be part of the solution set, one of them is going to be not part of the solution set. So, make sure you use that in your answer for number 9. For number 10, graph the following two variable inequalities. I started you off with this one. So you want to get y by itself. Okay, so I'm going to subtract 3 from both sides. So you're going to end up with y is greater than or equal to x minus some number. Okay, this is going to be your y-intercept. So you got to go way down here, whatever that, -4 minus 3 is. You got to put your point there. And then your slope is just a 1 because there's just one x there. So it's going to be up 1 over 1, put a point, up 1 over 1, put a point, up 1 over 1, put a point, make a line. Okay, so it's going to be down here somewhere, guys, and it's going to be going a positive direction like this. Okay. For number 10, I started you with number 10 also. I got rid of the 2x. I want to get the y by itself. So now you're going to have to divide by a negative for everything. Okay, when you do that, you're going to have to flip this sign. Okay, so remember, when you're dividing by a negative, you flip the sign. So it's going to be y is less than whatever this is, 2 divided by negative 4. Okay, and then put an x by it, and then 8 divided by negative 4, whatever that is. And then, that's going to be your y-intercept, and that's going to be your your slope. So go ahead and draw that out on a x and y coordinate. And extra credit, hey, you have many to pick from. Who is my favorite NFL team? That is Mr. Fry's NFL team, so good luck with that.